Hey guys, today we're going to be talking about triangles and the angles within them. Now, maybe you'll remember that there's 180 degrees in every triangle, so what we can do is we can use that information to work out what's left over. So in a triangle like this, hopefully we all remember what this symbol means. It's a right angle, and hopefully you also remember that a right angle is 90 degrees. So what we're going to do is there's a couple of ways we can do this. So I can say 180 minus 90 minus 40 is going to be the leftover angle, right? Because it's 180 in total. I get rid of these two and I can figure it out. So hopefully you can work out that that's 50 degrees. So this angle here must be 50 degrees. Normally we write it on the inside. I don't know why I didn't. Another way you could work it out is you could say 90 plus 40. So put that together and that's 130. Then I can do 180 minus 130, which would give me 50. Either way, you're still going to end up with 50 degrees, so I don't really mind which way you do it. All right, same thing here. This time I have no right angles. So all I'm going to do is say, what do these two things equal together? 32 plus 28. See if you can work that out in your head. Hopefully you came up with 60 degrees. So 180 minus 60. I mean, you can write it like this if you want. And altogether that's going to equal 120. Now clearly I have not drawn this to scale because that does not look like 120 degrees. I'm just trying to make a point with numbers, so ignore all my drawings, they are not to scale. All right, hopefully you remember what those two lines mean. It means that these two side lengths are the same, and hopefully you remember what kind of triangle that makes it. So this is a right angled triangle. Do you know what kind of triangle that is? Well, there are two ways we describe triangles. You can describe it by its angles or by its side lengths. So if I describe this by its side lengths, there are three different side lengths, and I know that because there are three different angle lengths or angle sizes. So this makes it a scalene triangle, or it's an obtuse triangle because I have one angle that's bigger than 90 degrees. All of these are smaller than 90 degrees or 90 degrees. This is a right angled triangle because it's got a 90 degrees. If this was less than 90, like this one's going to be, then it would be acute. So if all of the angles are under 90, you call it acute. If one of them is over 90, call it obtuse. Okay, so here I'm going to do 180 minus 70, which gives me 110. Now, if these two are the same size, hopefully you remember from an isosceles triangle, that makes these two angles the same size. So I have 110 and I need to divide it by two even sizes. So I have 55 degrees in each of these, and these are going to be the exact same size. All right, ignore that drawing. It was a terrible drawing. I'll try it again over here. So this time we have two different triangles. So if I know, just like over here, if these two are the same length, that makes these two the same size. And actually, I've already got one circle there, so I shouldn't draw just one little line because that would mean that these are the same size technically, and they are not. So 110 plus 20, that gives me 130. So what's left to get to 180? 50. So this is 50, which makes this one over here also 50. So then if I want to work out this angle in here, I'm going to do three lines to show that it's different. Well, this is one big triangle, isn't it? So if I have 180 minus 50 minus 50, hopefully you recognize that that's 100, gives me 80. So this angle here is 80, but this bit here is already 20. So that makes this bit here 60. Now, there are two different ways that I can do this. It is 70 degrees, and I'll show you the two different ways that we could do it. We can do 50 plus 60 is 110. So then 180 minus 110 is 70. Or I can recognize that these are, you should remember this from last year and the year before actually, these are called supplementary angles because they form a straight line, and any straight line is 180. So 110 plus 70 is 180. So I know that this must be a straight line. Either way, you'll get 70, so it doesn't really matter which method you use. Whichever one you would prefer to use is fine. The biggest clue here, if you didn't recognize that these two were the same length, which makes these two angles the same size, then you'd be stuck and you wouldn't actually be able to work out anything over here really much at all. So make sure you pay attention to any markings that you get. All right, this time we have an exterior angle. So we're still going to use the same idea as this in that we have supplementary angles. So if this bit's 120, this is a straight line. So what bit goes in here? It needs to equal 180. So that makes this bit 60. Now I can work out this one up here. So I've got 180 minus 60 minus 55. So hopefully you know that that is 65. And so, yeah, we end up with 180 degrees all up if you add those together. Okay, now this one here has absolutely no markings at all on the sizes of anything, but again, ignore my terrible drawings, but if I said that these three are the same length, that must mean that all of the angles are exactly the same size. So this is an equilateral triangle or an equiangular triangle. It is both of those. It's equilateral, same side lengths, and it's equiangular, 3 equal angles. So then I just have to do 180 divided by 3 equal sides, which gives me 60. So all of these are 60 degrees. Okay, let's move across to the next thing. So this is all we're going to do with triangles. We're just going to recognize that there's 180 degrees in every triangle, and we're going to use that information to work ourselves through to every unknown angle. Let me know if you're confused. Okay, this time I've drawn some shapes really terribly. As you can tell, I can't draw it. You will get to know that anytime we do geometry subjects. Okay, so one of the things we said before, that any triangle is 180 degrees. Now there is an algebraic formula I'm going to show you in a second, but I want to show you how this works with triangles because that's one of the ways the book is going to teach us about it. So what I'm going to do is I'm going to use this corner and I'm going to draw straight across, and I now have 2 triangles, right? 1, 2. So if we know that triangles have 180 degrees, I know that I've got 2 triangles. So if I want to know how many degrees are inside this shape, I just have to add together 2 lots of 180, which is 360. So hopefully you already know that fact, that there's 360 degrees in any quadrilateral. That means 4-sided shape. And so that's why this is true, but this is a little test that you can do. So if you've got more than 3 sides, 4 sides, however many you don't know, you can continue to make triangles to figure it all out. So for this one, same thing here. I might start from this corner this time. It doesn't matter which corner you start from. I'm going to draw one there, and I'm going to draw another one there. And I can't draw any more triangles, so I have 1, 2, and 3. So I've got 180 plus 180 plus 180 this time. And hopefully you know that really every time you add a side, maybe you can tell, every time you add a side, you just add an extra 180 degrees. So that's going to give me 540 degrees in total. Now this is known as the sum of the interior angles. Sum just means adding them all together. Interior is the inside. So the sum of the interior angles of a quadrilateral is 360. The sum of the sum of the interior angles of any 5-sided shape is going to be 540. Now, if you're more inclined for algebraic rules, then I'm going to teach it to you. If this is all you can handle, that's fine with me. But you do have this lovely rule that says this, and n is the number of sides the shape has. So if I want to figure out how many sides a shape has, let's say that I have a 12-sided shape and I want to know what I'm doing. So 180, 12 minus 2, right? So 12 minus 2 is 10. So 180 times 10 is 1,800. So that means any 12-sided shape has 1,800 degrees as the sum of the interior angles. All right, so this is a nice little rule that you can use, but the book is teaching us the triangular method. All right, so over here, let's pretend all these sides are the same length, and let's also pretend that all these angles are the same size. Let's pretend I'm a better drawer than I am. Or let's pretend that I just used a ruler and a compass when I didn't. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8. So we could use this rule here and say 188 minus 2. So that's 180 times 6. And if you want to work that out, you can use a calculator or do it on paper. You should have 1,000, so 1,080 degrees. That's how many degrees are on the inside of this shape. But if the question asked me to find one angle, so what is the size of one interior angle? Well, now that I know what they all are and they're all the same size, can't I just divide it by 8? Of course I can. So if you take that number and divide it evenly between all the sides, you will have 135 degrees. So that means each one of these is 135, and that looks about right. They're definitely bigger than right angles, so it's got to be more than 90, and they're definitely less than a straight angle, which is 180, so this sounds about right to me. It's good to use your common sense. If I got a number like 300, I'd go, whoa, that's way too big, that doesn't make sense. there are 360 degrees in a circle, so almost that is almost a full revolution. That wouldn't make sense. Or if I got a number under 90, I'd also know that was wrong because this is bigger than a right angle. Okay, same thing here. Again, you can use this triangular method. It does seem like more work to me, but if I drew all of these lines, okay, so I've got 1, 2, 3, 4, 5, 6. So really, just like here, I'm doing 180 times 6, aren't I? Isn't that what I said the rule was anyway? So 180 per triangle, and there's 6 of them. That's why this rule works so well. And then I would have got 1080. And same thing, once you've got all of that together, you just divide it by how many angles there were. Okay, let's try that one more time. This time I have 6 sides, 1, 2, 3, 4, 5, 6. So again, you could draw some triangles if you wanted to, and you've got 1, 2, 3, 4. But the rule says that there's 6 sides, so 180 times 4 is going to be 720. So if I, again, wanted the size of one interior angle, so I've got 6 different angles, so I'm going to do 720 divide by 6. So you can work that out yourself through using short division or even a calculator if you really want, and you should get 120. So each angle is 120. Now there's one more thing that you're going to be asked to do, and that's finding the exterior angles. So what I'm going to do is I'm just going to draw lines of all of these ends. Okay, so what you can see is that every single, I'm going to try and pick a different color. So every single angle here matches up with something on the outside, like that. Probably shouldn't have picked pink and red, should I? They're a bit too close in color. Okay, so all of these, don't they all create a straight line? So these are all supplementary angles. So as long as I know the inside one, I can easily figure out the external one. So if I know the inside, the interior angle is 120, well, the exterior is 180 minus 120, which is 60. So the size of one exterior angle is 60 degrees. Now there's one more rule about external angles, and exterior angles always add to 360. Always, always, always. So if I wanted to add 1, 2, 3, 4, 5, 6 of them together, there are 6 exterior angles because there are 6 interior angles. So if I did 6 times 60, that's 360. See how I told you it always works? Same thing here. I'll prove to you that it always works over here. So all of these, if I drew a straight line, whoa, there goes my, oh, that's right, that pen's dead. If I draw a straight line that comes off all of these, I promise they will all add up to 360. So we know that each interior angle in this case was 135. And remember, this straight line has to add to 180. So that makes each exterior angle 45. And how many are there? Well, there were 8. That equals 360. So just like over here, 60 times 6 equals 360. Always, 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 always. Exterior angles will always add up to 360. So you can either say there are 8 sides here. So if I do 360 divide 8, I'll get the size of one exterior angle. Or you can say the interior angle is 135 and subtract it from 180. Either way, you're going to get the same answer. I don't mind which method you use. All right, I know that was a fair bit of information in one video, so you can go back and re-watch anything, or you can come and ask me questions. I'm quite happy to work through this if you're not quite there yet. Okay, come and see me if you need some help. Good luck.